Hello, this is Walker Rowe. Do you want to be a chip designer, understand how a computer really works, work in robotics, or be an embedded systems engineer? Well, watch this video. I explain to you how to use a shift register. It's a simple way to control more than one output. So it's a register, which is a CPU also has a register. So it's a way to store memory of 8 bits and control an output. It's the first step toward learning about how a CPU works. In this lesson, we're going to connect a shift register to an Arduino. A shift register lets us control several outputs while only using a few Arduino pins. One shift register can control 8 LEDs. But to keep this first example easier to understand, we will connect and illuminate only one LED. Here's the pin diagram. As you can see in the diagram, when the chip is pointed up with the notch on top, the numbers on the left start at 16 and go around counterclockwise to 1. Here's how we will connect the pins. First, you push in the chip on the breadboard across the gap in the middle. The legs are not perfectly aligned, so it might take a few tries. I find it works best to come in at a small angle rather than straight down. Then push the chip in firmly. Pin 16, called VCC, connects to 5 volts. Tinkercad uses slightly different names, more space to write those names. Pin 8 connects to ground. Pin 14 is the data input. We will connect it to Arduino pin 4. We will explain what data and other terms mean shortly. Pin 12 is the latch pin. We will connect it to Arduino pin 5. Pin 11 is the clock pin. We will connect it to Arduino pin 6. Pin 10 connects to 5 volts. And pin 13 connects to ground. Pin 9 is only used when connecting another shift register. We are not doing that today, so we will leave pin 9 disconnected. The shift register has 8 outputs named Q0 through Q7. These outputs can each control a LED or another electronic component. Notice that Q0 is physical pin 15 on the chip. In this example, we will connect a resistor and a LED here and then go to ground. If you want to add 8 LEDs, then you just use all the pins on the other side, Q1 through Q7. The Arduino communicates with the shift register using 3 wires. The wire is the data wire. The data wire carries the 1s and 0s that we want to store inside the shift register. The second wire is the clock wire. Each time the clock pulses, the shift register accepts 1 bit from the data wire. The third wire is the latch wire. The latch tells the chip when to move the completed value to its output pins. You can think of it like this. Data pin says, here's the next bit. Clock pin says, accept that bit now. The latch pin says, the complete number is ready. Show it on the outputs. The complete number means, for example, suppose that the Arduino sends the binary value 111, 8 ones. This value contains 8 ones, 1 bit for each output from Q0 through Q7. After the latch is activated, each output pin becomes high, so all 8 LEDs turn on. If Arduino sends 7 zeros and then a 1, only 1 output becomes high. If it sends 4 zeros and 4 ones, 4 outputs become high and 4 remain. We give names to the 3 Arduino pins. The data wire connects to Arduino pin 4. The latch wire connects to Arduino pin 5. The clock wire connects to Arduino pin 6. Inside setup, we configure all 3 pins as output. The Arduino sends signals through these pins, so they must be outputs. Inside loop, we call show byte and give it the binary value that we want to display. This value will turn on Q0. Now let us examine the show byte function. First, we set latch pin to low. This tells the shift register, do not change the visible outputs yet. I'm still sending the new value. Next we use shiftOut. This has 4 parameters. Data pin is the wire that carries each bit. Clock pin produces 1 pulse for each bit. MSB first tells Arduino which end of the binary number to send first, and value is the 8-bit number being sent. The Arduino sends all 8 bits one at a time through the data wire. For every bit it pulses the clock wire. This lets the shift register to store the bit and prepare for the next one. After all bits have arrived, we set the latch pin to high. This transfers the stored bits to the output pins. Q0 then becomes high, and the LED connected to Q0 turns on. Now let us build the circuit. First, place an Arduino Uno and a breadboard into the workspace. Next, place the register across the center gap of the breadboard. The center gap keeps the pins on 2 sides of the chip electronically separated. Make sure the chip is facing the correct direction. Use the notch as your guide. We will begin with the 3 control wires. Connect Arduino pin 4 to pin 14 on the shift register. This is the data connection. Connect Arduino pin 5 to pin 12. This is the latch connection. Connect Arduino pin 6 to pin 11. This is the clock connection. Now we need to power the chip. Connect the Arduino 5-volt pin to the positive rail of the breadboard. Connect an Arduino ground pin to the negative rail. Connect shift register pin 16 to the positive rail. Connect pin 8 to the ground rail. Pin 10 is the master reset pin. We're not using the reset in this project, so connect pin 10 to 5 volts. This keeps the reset disabled. Pin 13 is output enabled. Connect pin 13 to ground. Leave pin 9 disconnected. We only need pin 9 when connecting another shift register. Finally, add 1 LED to the breadboard. Connect output Q0, which is chip pin 15, to the LED through a 220 ohms resistor. The resistor protects the LED from excessive current. Connect the other side of the LED to ground. Remember that a LED has a direction. The longer leg is the anode, or the positive side. The shorter leg is the cathode, or negative side. In this circuit, the output from pin 15 should travel through the resistor and LED and then return to ground. Now start the simulation. The Arduino sends the binary value 7 zeros and a 1 to the shift register. The data pin sends the bits. The clock pin tells the chip when to accept each bit. The latch pin then moves the complete value to the outputs. Q0 becomes high, so the LED connected to pin 15 illuminates.